Hello guys, welcome back. If you are new here, I'm Dr. Sagacious. I'm a first year medical student of the University of Ibadan and I am an academic coach. Alright? So in this video, we're going to be looking at the day one JAMB Chemistry live questions. Alright? I have some live questions from students that wrote today and I'm going to be sharing them with you, sharing the solutions with you because there is a tendency that maybe one of them might be repeated in your exam and it's more like a bonus question for you. All right, so stay with me till the end. Let's dive in. So question number one says, which particle determines the identity of an element? Which particle determines the identity of an element? Option A, neutron. Option B, electron. Option C, proton. Option D, nucleus. Right, so the answer to this question is what? Option C, proton. Why? Because the proton number is equal to the atomic number. So without knowing the proton number or the atomic number of an element, we are looking for the identity of an element, right? Without knowing the proton number or the atomic number of an element, you cannot know where to place that element in the periodic table. It's safe to say that you don't even know the elements we are talking about, right? It is the proton number that tells you, okay, this is the element we are referring to. When you hear proton number 17, that tells you that it's what? Chlorine. If you hear proton number 3, that tells you what? That we are referring to what? Lithium. Do you understand? So it is the proton number. Or if you just say electron number, though electron number can be equal to the proton number only for neutral bases. But in this case, the correct answer and the most preferred answer to this question is proton number. So proton option C is correct. Alright. Question 2. Which trend is correct across period 3 from sodium to chlorine? From sodium to chlorine. Now when you draw the periodic table, right, in period 3, what do you have? You have sodium, magnesium, aluminium, silicon, and so on and so forth. Alright, so that's on period 3. Do you understand? So what happens as you move from left to the right? That is from sodium to chlorine, to meet chlorine. You are moving from left to the right of the periodic table. So let's have the options and analyze them. The question says, I repeat the question, which trend is correct across period 3 from sodium to chlorine? Option A says atomic radius increases. Is that correct? No, because they are in the same period. So when you're talking about atomic radius, you're talking about the size of an atom. So basically, generally, on a general, if you followed my final revision session on chemistry, you realize I said something about atomic radius, this trend. I mentioned it in the class. And if you're in the class, you should know the answer to this question by now, right? So across the period, atomic radius does what? Decrease. It decreases, so it does not increase, but it increases when you go down. Why? Because as you go down the group, you keep adding more shells, and more shells will entail that the size of the atom will increase. Do you understand? So that makes option A wrong. Option B says ionization energy decreases. That's also wrong. Ionization energy increases as you move from left to the right of the periodic table, then decreases down the group. Option C says electronegativity increases. That's correct. I gave you three. I grouped them into two. The three that increase across the period and decrease down the group, and the ones that do the opposite. Alright? So I'm going to repeat them. Ionization energy, electron affinity, and electronegativity. Take note of them. Ionization energy, electron affinity, electronegativity. These three will always do what? They will always increase across the period. They will always increase across the period. Don't forget, ionization energy, electronegativity, and electron affinity. When it comes to periodic trends, those two that start with E, they will always increase across the period. On a general note, I don't want to start explaining the reason behind them now, but on a general note, just know that they will always increase. So remember IEE, alright? More like electronic engineering. Use it to remember it. Or you can say International Electronic Engineering. It doesn't really, but it's just anyhow you want to remember it. Just know that those two that has letter E are always increasing across the period alongside ionization energy. That means they will do what? They will decrease down the group. Alright? So then for the ones that you have atomic radius, ionic radius, and metallic character. Aim: atomic radius, ionic radius, and metallic character. This metallic character is also known as electropositivity. Electronegativity is also known as what? Non-metallic character. So don't forget, right? So these three will now do the opposite. They will decrease as you move from the left to the right of the periodic table and increase as you go down the group. So that makes option C correct for number 2. Question 3 says a gas occupies a volume of 1.2 dm cube at STP. How many moles is it? This is a very cheap question. If you followed my video on stoichiometry, I gave you a particular formula. I gave a list of formula anyway, but this particular, you remember this particular formula that says that number of moles is equal to what? Volume, that is the given volume, divided by molar volume. This is molar volume in dm cube. That's if the volume is in dm cube. As in this case, our volume is in dm cube, so our molar volume will be in dm cube. This molar volume is according to Avogadro that at STP, every gas will occupy what? 22.4 dm cube. At STP, every gas will occupy 22.4 dm cube. Don't forget this formula. You will need it in your exam. As you can see in day 1, it has already started surfacing. Alright, so how do we attack the question? Simple. Divide the volume. The question says a gas occupies 11.2 dm cube at STP. How many moles is it? So simple. Number of moles is equal to the volume, which is 11.2 divided by 22.4. Looking at this, 11 is half of 22. 2 is half of 4. So what does that tell you? It tells you that the answer is what? 0.5. That's half. 0.5 dm cube. And that's option B here. Alright? Let's move. Question 4. An element occupies, I read that again. An element has isotopes. Alright? Let's do this. An element has isotopes 65X. This is the element. 25%. And 67x, 75%. The question says, what is the relative atomic mass, or what is its relative atomic mass? Option A 65.5, option B 66, option C 66.5, options D 67.0. As you can see, these answers are approximately close to each other, right? So what do we do? That means we have to get the exact answer. So let's go. When you are talking about relative atomic mass, what comes to your mind? Now let's see. Relative atomic mass, RAM, is equal to M1 times abundance of M1 plus M2 times abundance of M2, if there are 3, plus M3 times abundance of M3 divided by total abundance in percentage, which is what? 100%. The total abundance will always give you 100%. As you can see here, 25 plus 75 will give you 100%. Sometimes they leave it in whole number form, which will give you what? Sometimes it can be in terms of fraction anyway, right? But you can always convert it to percentage if you want to use percentage. If it's 1/4, 1/4 converted to percentage, 1/4 times 100. Do you understand? So it's that simple. So we solve. That will give you mass of this is what 65. Mass of an element is always written on top, while the proton number is always written below. I'm just using third side. I'm not saying that's the proton number of this. Alright? Proton number is always written below. Do you understand? Here. Why mass number is always written. So if you want to get the neutron number, subtract the proton number from the mass number. Whatever thing you get is the neutron number, just in case, right? You might see a question like that. So mass number is usually denoted. Let me use a different ink for that. Mass number is equal to neutron number. That's what we're talking about. Neutron number is equal to mass number minus proton number. You understand? If you want to get the neutron number, subtract the proton number from the mass number. So let's move. Now back to our question. M1 is what 65 times the abundance is what 25 plus M2 is what 67 times the abundance is what 75 divided by 100. Let's do the math. Quickly. 65 times 25 will give you what? This is 1625 plus 67 times 75, 5025 divided by 100. So add up. This will give you 6650 divided by 100. And what do you have? 66.5. 66.5. And that's which option? Option C. So option C is the correct answer to this question. Next question. Question 5 says, which arrangement shows increasing atomic radius? Remember initially I said that atomic radius increases down the group and decreases across the period. So when we are looking at the one that shows increasing atomic radius, what it means is that we are looking at where a list of atoms are going down the group because it increases down the group, right? Now, there's also something I want you to know. Whenever you're dealing with science, you will always see something like, okay, let me read the options for you. Option A says, this is option A, potassium less than sodium less than lithium. Potassium less than sodium less than lithium. Option B, lithium less than sodium less than potassium. Option C, sodium less than lithium less than potassium. Option D, lithium less than potassium less than sodium. They even made it easy by using less than throughout. It's easy for sometimes they'll use, if I were the examiner, I'll use both less than and greater than to confuse you. Right? So whenever you're arranging in increasing order, that is because the question says shows increasing atomic radius, you'll always use less than, because this means that this is less than this and this is less than this. That means if this is less than this, that means this is greater than this. It is increases from the smaller one to the higher one. So whenever you're arranging from increasing order, you make use of what? Less than. But if you're arranging in decreasing order, you make use of greater than. Don't forget it. If you're arranging in decreasing order, make use of the greater than sign. Alright? Now, how do we analyze this question? In the periodic table, these three elements in the question are in the same group. Lithium comes first in group 1, right? Lithium comes first, followed by sodium, followed by potassium. This is the way they are arranged in the periodic table. So that means this has the smallest atomic radius, followed by this, followed by this. So the correct answer is what? Option B, that says lithium is less than sodium and sodium is less than potassium. This is our answer. Alright, so that's it. Question 6. What is the empirical formula of a compound containing 40% carbon, 66.7% hydrogen, and 53.3% oxygen? Right? Let's solve. So let me read the question again. The question says, what is the empirical formula of a compound containing 40% carbon, 6.7% hydrogen, and 53.3% oxygen? So when you have a question like this on empirical formula or molecular formula, first thing you have to do is to do what? Write out the constituent elements, right? You have carbon, you have hydrogen, you have oxygen. Next thing, write out the percentages. You have 40%, you have 6.7%, and you have 53.3%. Now, divide through by their molar masses. It was not given in the question, so you have to know them. You have to know the molar masses of the first 20 elements. You have to know the molar masses of some common transition metals like iron, mercury, lead, and so on and so forth. Alright? So, divide through, we are going to have 12 here. You have 1, and you have 16. When you divide this, you are going to have what? 3.3. Divide this, you are going to have 6.7, and you are going to have 3.3. Next thing is to do what? Divide through by the smallest ratio. The smallest ratio is here is what? 3.3. So divide by 3.3, divided by 3.3, divided by 3.3. And you're going to be left with the ratio of 1:2:1. Therefore, the empirical formula of the compound is C1, which is written as C, H2O1. This is the empirical formula, and that's what option A. Alright, let's move. Question 7. Which of the following gases is a noble gas? This is one of the easiest questions. Option A, chlorine, B, neon, C, oxygen, D, nitrogen. The correct answer is neon. So, by the way, just in case you don't know the common noble gases. Noble gases from the periodic table, we have helium, you have neon, right? You have argon, you have krypton, and you have xenon, right? These are the noble gases that we have. So you can call them noble gases, or you call them, this is xenon, this is krypton, this is argon, this is neon, and this is helium. They are the least reactive elements in the periodic table. So you can call them noble gases. I've said this before in my revision class: noble gases, or rare gases, or inert gases. Noble gases, rare gases, inert gases, whichever one you call them is correct. Question 8. Which ion has the same electronic configuration as argon? Now, right? Argon is what? This is argon. The atomic number of argon is what? 18. So what it means is that we are looking at the option that the atomic number will give us 18. We don't even need to start doing the electronic configurations. That's a waste of time. Just find the element or the ions instead, because the question says which ion is. So find the ion that the atomic number will give you 18, right? That's the proton number will give you 18. Or you say the electron number. The electron number will give you 18. That is because we are dealing with electronic configuration. So it's safe to say the ion with the electron number of 18, that will have the same electronic configuration as argon. So option A says potassium ion. Now, the atomic number of potassium is 19. Potassium is the 19th element, alright? But it has a plus charge. Remember what I told you about plus charges? That plus means loss of electron. So because it has one plus charge, it means that it lost one electron. And when it loses one electron, what is going to be left here? You are going to have 18 electrons left. What it means is that potassium ion has the same electronic configuration as argon. Next, you have calcium ion. What's the atomic number of calcium? Calcium is the 20th element in the periodic table. So, and it loses 2 electrons. Plus means loss of electron. Don't forget it in your life, right? So when it loses 2 electrons, 20 minus 2 will give you what? 18. So that means calcium ion also has the same electronic configuration as argon. Option C, chloride. Atomic number of chlorine is what? 17. Atomic number of chlorine is what? 17. It has a minus charge, meaning that it gained 1 electron. Minus 1 charge means gain of 1 electron. So when it gains 1 electron, this will turn into what? 18. 17 plus 1 is what? 18. So that means chloride also has the same electronic configuration as argon. Option D says all of the above. So the correct answer to this question is what? All of the above, because the 3 listed options have the same electronic configuration as argon, right? Question 9. Which bond is most polar? This is the easiest question. Option A, hydrogen to hydrogen. Option B, hydrogen to chlorine. Option C, chlorine to chlorine. Option D, oxygen to oxygen. Now, a smart student who doesn't know what polarity entails can quickly pick B. because you'll be like, this element and this element are the same, this one and this one are the same, this one and this one are the same, these two are different, that means it's most likely going to be this one. And funny thing is that you are correct, right? But you don't know why. Now when you talk about polarity has to do with difference in electronegativity value. Remember, I said that electronegativity increases across the period. So elements towards the left hand side of the periodic table have higher electronegativity value, while elements towards the left hand side have lower electronegativity value. Now, polarity of a compound usually arises when you have an element towards the left hand side combining with an element towards the right hand side, because the difference in electronegativity value will be much, at least it will be greater than 0.5, right? So most times when the difference in electronegativity value is greater than 0.5, most times that compound is said to be polar, right? That compound is said to be polar, meaning it has a net positive and negative charge. The element towards the left hand side has a partial positive charge, and the element towards the right hand side has a partial negative charge because it's electronegative. So the more electronegative element which will appear towards the left hand side, right hand side of the periodic table will have a partial negative charge, while the one towards the right, towards the left instead, will have a partial positive charge. Do you understand? So that's why they call them polar. Polarity means having two poles, right? Two charges, partial charges. Do you understand? So now, if you look at the first option, in fact, all other options, they have the same elements. So the electronegativity value, if the electronegativity value of hydrogen is 2.1, that means 2.1 minus 2.1 will give you 0. The same thing happens here. The same thing happens here. But for this, you can have something like 2.1 and maybe 3.5, right? When you subtract them, you're going to have a difference greater than this. Do you understand? Meaning that this is polar, right? Because this is from towards the left hand side. So elements towards the left hand side, they usually have lower electronegativity value, while the ones towards the right hand side, they usually have higher electronegativity. So when you do the difference, you're going to have a difference greater than this, meaning making them polar. So most times electrovalent compounds or ionic compounds are usually polar. Alright, so that makes this the correct answer. Then the last question for today, for this particular session, says in electrolysis of molten sodium chloride, what is formed at the cathode? In electrolysis of molten sodium chloride, what is formed at the cathode? So the cathode, first of all, you have sodium chloride, right? Now let's take them singly. The cathode is the, now we have two electrodes, the cathode and the anode, right? So just use that. When you know that cation is positively charged ion, then you know that the opposite, that cathode is negative electrode, right? While anode is the positive electrode, right? So now, if cathode is a negative electrode, what it means is that the positive ion will be attracted to the negative electrode, while the negative ion will be attracted to the positive electrode, which is the anode. So now, sodium will lose an electron, right? If sodium loses an electron, it will attain a positive charge, right? Making it attracted to the cathode, right? If chlorine loses an electron, gains an electron, it will attain a negative charge, making it attracted to the positive electrode. So the sodium ion will form its metal, while the chloride ion will form its gas, that's chlorine gas, right? Like the normal state, chlorine in its normal form is expressed as this, and sorry, I mean sodium, while chlorine is just diatomic, sodium is monatomic. All right, so since sodium is the one attracted to the cathode, sodium metal will be discharged. Why? While chlorine gas will be discharged at the anode, right? So the question says, in electrolysis of molten sodium chloride, what is formed at the cathode? Chlorine gas is formed at the anode. The cathode is where sodium went to, so sodium metal will be formed at the cathode. So that's it for this video for now. Bye for now. We'll see you on our next video. Make sure you share with your friends, like our video, subscribe, and stay tuned for more. Bye.